Hi everyone, welcome back to the channel. This is day 5 of the Kubernetes playlist Beginner to Pro. In today's session, we are going to learn the fundamentals of YAML. Because YAML is the language we will be using to write almost all Kubernetes manifest files. So what we will cover today? First, we will understand why YAML is so important in DevOps and what exactly this language is all about. Next, we will break down the simple structure of YAML file and see how indentation drive everything. Then we will explore different data types you can use inside YAML like strings, numbers, list and objects. Finally, I will show you how to read and access YAML data directly with a short Python program. Now let's see why we need YAML and how YAML or commands work inside a Kubernetes cluster. When working with Kubernetes, we interact with API server through a CLI called kubectl. You can think of it as talking to a cluster using command line tool. With kubectl, we can create, update or delete resources inside the cluster. For example, whenever we type a command like kubectl get pods or kubectl create deployment, kubectl sends that request to API server through a REST API. See, although we already discussed the Kubernetes architecture in day 2, here is a quick recap only. The API server is like a front door of Kubernetes. It checks the request, makes sure it's valid, and then talks to the rest of the control plane components. Inside the control plane, we have etcd, a database that stores the entire cluster state. Kube scheduler decides on which worker node each pod should run. Kube controller manager keeps watching everything to make sure the actual cluster state always matches what we asked for. See, once a scheduler picks a worker node, the request falls down to the worker node. Each worker node runs a kubelet, an agent that communicates back to API server and ensures the containers are running, and a kube proxy which handles networking and load balancing. Finally, the actual containers are created by the container runtime, maybe be it Docker, Containerd or Podman, and they run inside pods. See, pods are the smallest deployable units inside Kubernetes. So complete flow is we have kubectl, then API server through the other control plane components, then worker nodes, and then the running pods. So this is how simple command from your terminal runs into running application inside the Kubernetes cluster. Now there are two main ways to create or update components in Kubernetes. The first one is imperative way, means directly running the commands like kubectl, run, then pod name. Another one is declarative way, by writing manifest files either JSON or YAML and then apply them using kubectl. Let's discuss the imperative way first. I will show you by running a command to create a pod. I already have a cluster ready which I created earlier using kubeadm, so I'm using that. Let's first check the nodes in the cluster by running kubectl get nodes. This shows me one master node and one worker node is ready to schedule workloads. If you are running this on your own setup, you might see more nodes depending on how your cluster is being configured. Now, for example, if I want to quickly test a command inside our Kubernetes cluster to create a simple Nginx pod, I can run kubectl run, then pod name -- image is equal to image name :version. This command tells Kubernetes to create a pod named Nginx and pull the latest Nginx image from Docker Hub directly. It's an imperative command, which means we are giving Kubernetes a direct instruction to spin up this pod immediately. No YAML file is required. So this is perfect when you just want to test something quickly or verify that your cluster is working. So after running this command, we can check the pod status with kubectl get pods. So my status is running this time, and one by one pod is ready. So pods can have different statuses. Such as pending. Pending means Kubernetes has accepted the pod, but one or more containers have not yet been created. The scheduler may still be finding a suitable node. Next can be container creating, means images are being pulled from the image registry and the containers are started on the selected node. Next is running. Running means all containers are up and running as expected. This is the healthy state which we usually want. Can be failed. At least one container terminated with non-zero exit code, meaning something went wrong during the startup or execution. Status can be crash loop backoff, which means a container keeps failing and Kubernetes is restarting it repeatedly but backing off each time. This usually points to configuration error or bug in the container image. Sometimes it can be image pull backoff or error image pull, means Kubernetes cannot pull the specified container image. Something went wrong, maybe the image tag is incorrect or the image simply isn't available in the registry. So in that case, always double check the tag and registry URL. So sometimes you might also see the condition like terminating, which means a pod is in the process of being deleted. Okay, so it's important to get familiar with all these statuses because they tell you exactly what is happening inside your cluster. So to get the detailed information about your don't worry, we will go deeper into these statuses in upcoming sessions. To summarize this, we can say imperative method is great for quick tests, demos or troubleshooting, but it's not ideal for production because it does not provide a reusable or version control configuration. For production, we use YAML files in the declarative approach, which we will explore next. For now, let's focus on YAML basics, where we define the desired state of our application and let Kubernetes handle the rest. Now let's start with today's main topic, which is YAML. So YAML stands for YAML Int Markup Language. Originally, it was yet another markup language. It's not just for Kubernetes. It's also used in Docker Compose, Terraform, Prometheus, Ansible, Helm, and many other tools for writing configuration files. So, to understand these tools, we first need to understand YAML well. It is the most popular and widely used format across different DevOps tools and applications. YAML is a serialization language similar to XML and JSON. It stores data as a key value pairs, so different applications can share data easily. YAML files have an extension of .yaml or .yml. YAML stores information as key value pairs and objects, making it simple and human-friendly language to read and write. So here is how a sample YAML file for storing application configuration might look. We have a root key called Spring Boot API, and inside it we define key value pairs for the app name, the port number and the version of the application. Notice how the indentation is consistent. Here we use 2 spaces. Also, keys are case sensitive, so choose a clear naming style like camel case, Pascal case or all lowercase. If the indentation is not proper, you will get an error. So YAML data is built from key value pairs. It can be lists, also objects. Objects are also called dictionaries, and this is an example of object only. I have created a public GitHub repo called Kubernetes playlist where I will store all the YAML files for this series. And inside Visual Studio Code, I will write YAML files and push them to GitHub. I recommend you to create your own repo too, so you can practice and compare with my YAML files in the GitHub repo. So each day will have its own folder. Today's files will be inside day 5. Let's create a file named simple.yaml. And add some data here. Name, Tom, age 30, married, true. So this file stores 3 basic key value pairs. Name is a string and quotes are optional unless special characters are used. Age is an integer, married is a boolean value. So if I write employees on the top of this data and provide some indentation, so it will become an object. We can say employee is an object containing details of Tom. So we have created an object employees with multiple properties. So we can add list of employees using hyphen. So if I give hyphen here and provide indentation properly, also add another data, name Lucy, age 25, married, false. So here employees is a list of objects. Each object is marked with dash and contains its own set of key value pairs. So we can create simple list as well. Employees colon hyphen Tom Lucy. This is simple list of strings where each dash represents a list item. So we can create nested list and objects as well. For example, if I want to add one more field here, skills for each employee like Python, JavaScript, also the same way for the another employee as well. So this is the final example. Each employee object contains another list called skills. This shows how YAML supports nested structure, making it perfect for Kubernetes manifest files. So there are few key tips. For example, always use spaces, never tabs. 2 spaces per level is common. So be consistent with indentation, and YAML is case sensitive, so keep naming clear and uniform. And also we can use hash symbol for comments. For now, let's remove the employees list for a moment and let me show you how we can retrieve or use the details using a Python program. So well, this is not important from DevOps or Kubernetes point of view, just wanted to show you how we can retrieve. So for that, create a file retrieve details.py, and we will need PyYAML library. So this is already installed in my system. I can show you pip list pipegrep-i PyYAML. So it shows PyYAML version 602 is available. So first we import the PyYAML library, which allows Python to read and work with YAML files using import YAML. Next we use the with open block with open. So here provide your YAML file name, which is simple.yaml. So here we are opening this simple.yaml file in read mode. This ensures the file is automatically closed after we are done. So we don't have to worry about accidentally leaving it open, or which is a good practice in Python. So next we will call yaml.saveload. Safe load. So here we are calling yaml.saveload to safely load the YAML content and store it inside a dictionary, Python dictionary called details. Next, print this details dictionary. Print full YAML content. So printing the details dictionary will show the entire YAML structure exactly as Python interprets it. Next we want to print each employee details including their skills, so we will use for loop for emp in details, and here name of our object, which is employees. Employee name, employee ID is not there, employee age is there, age, and then married. And then employee skills. So if we run the program using py retrieve details.py, so you will see the full YAML content here, and followed by each employee's details and their list of skills. Okay. So before we wrap up today's session, let's take a look at simple pod.yaml. So here first thing is API version (v1), which defines which Kubernetes API version we are using. Here v1 is the default core API version. Then we have kind is pod, which tells Kubernetes that this resource is a pod. Then we have metadata. Metadata contains basic information about the pod, such as its name and the labels, etc. Spec, this is the heart of a pod. It describes the containers that will run inside it. So each container here is defined as an object inside the containers list. You can have multiple containers inside a single pod. For each container, we specify name, image, if which ports we are using, and if there is any volume mounted, then volume mounts, etc. In this example, we also have a sidecar container, which is common for additional services like secret management, logging, and monitoring. So well, that's it for today's session on YAML fundamentals. In next video, we will apply this knowledge to write a Kubernetes manifest step by step. If you find this helpful, don't forget to like, share, and subscribe to the channel for more Kubernetes sessions from beginner to pro. Thank you.